change in the concentration of, there's somebody trying to get in. Okay, so the axon terminal is where the synapse is a gap between one nerve and another. And chemicals are used to carry the nerve impulse, and the nerve impulse causes the release of neurotransmitter like dopamine or adrenaline or norepinephrine or serotonin. Those are all the uh, some neurotransmitters. So within the nerve itself, the action potential is an electrical signal caused by changes in the amount of sodium coming in, then the potassium coming out, and that electrical event, that change in potential or charge, because you're changing the amount of sodium in the cell and then the amount of potassium in the cell. And this takes very, very little low concentrations, but those changes in concentration of the sodium and the potassium allows for opening and closing of these channels, and that electrical impulse is set to move away from the cell body to the axon terminal, and that communication is taken place by uh, chemicals that are released at uh, the axon terminal. Okay, so let's look at what it looks like. So the gap is called the synapse. The postsynaptic membrane is the membrane of a muscle or could be another nerve cell. The synaptic cleft is the gap. So the nerve impulse is going to come down and it's going to cause the release of neurotransmitter from these vesicles. And that neurotransmitter is going to open channels on the postsynaptic membrane that allows for a nerve impulse to start in the postsynaptic membrane, in the postsynaptic cell. So at the synaptic knob, at the end of a axon, will be this little knob or terminal that contains vesicles that contain neurotransmitter, which is going to be released, and that's going to uh, send a chemical message for the electrical signal to start by opening up membranes where sodium begins to flow in again. We're not worried about these. We're not going to know those. Okay, so here we have a presynaptic neuron, a postsynaptic cell, and these are channels. These channels are closed. What happens is calcium, as the voltage changes in this presynaptic cell, calcium moves in. That causes neurotransmitter to be released. That opens up these channels in the postsynaptic membrane, and that allows sodium to come in. And that movement of sodium, uh, that extra positive charge, is going to allow the electrical impulse to continue to move by opening channels and closing channels. And that's the nerve spike. It starts at the axon hillock and it always flows away from the cell body and the axon hillock to other terminals. So neurons are constantly based upon stimulation, like when you have light striking your eyes, you're going to be turning on uh, action potentials. When you hear something, when your muscles move, the what happens is the movement of an electrical signal on differences in charge. So imagine you have your uh, muscles. If you want to walk or you want to control your computer, for a muscle to contract, it must receive a nerve impulse that releases neurotransmitter that causes the electrical signal to start in the muscle, for instance. And that electrical signal leads to the contraction process. Okay, we're not going to worry about that either. Okay, drugs can affect these interactions at the pre and postsynaptic cell membrane. If you've been under surgery, obviously a lot of communication between a presynaptic cell and a postsynaptic cell has been blocked. Okay. Drugs can affect your perception, motor control, and emotions. Okay, the meninges are the layers of the cell. These are the layers that surround the central nervous system, the brain, and the spinal cord. There's the dura mater, the arachnoid, and the pia mater. Tough outer layer, spidery intermediate layer that has cerebral spinal fluid, and then pia mater is the very, very fine membrane that's attached to the brain material. So here's your skull, here's your dura mater. You have a dural sinus, inner dura mater into the arachnoid matter, and the last membrane is the pia mater. So this is where the cerebral spinal fluid is circulating. If you look at the spinal cord, you have an epidural space. Then you have the dura mater, the arachnoid, the subarachnoid, and the pia mater. So these are all protective. Dura mater, the arachnoid and subarachnoid space are for where the cerebral spinal fluid is flowing to provide food, minerals, pick up waste, and so on. Spinal cord basics. So information to and from the brain goes up and down the spinal cord. Spinal cord can do some processing on its own and thus identify these other structures in a picture. So this is the general anatomy of the spinal cord from the cervical, thoracic, lumbar, and sacral spine. So information is constantly being moved up to the brain and out of the brain. So if we look at a cross section of the spinal cord, here we have uh, the sensory information that comes into the spinal cord, travels up the dorsal root and through the dorsal root ganglion, which was the cell body is, into the gray matter, and it's processed and sent out the ventral root, for instance, to cause muscle contraction. That can happen. You don't have to be aware of it. As I move my mouse around, uh, I don't think about it. I just do it. And that's just from practice and uh, doing this process over and over. So that's a process that can take place within the spinal cord. That information is then, this is white matter, and that information that you're aware of movement. So I know my hand is moving. That information is carried up an ascending track of white matter into the uh, the brain and the different areas of the brain. If we look at how this gray matter is organized, here again, sensory information is going to come through the dorsal root ganglion, through the dorsal root, and it's going to go to the neurons, the association neurons that process sensory information, information from your gut, bladder, lungs, uh, all the things that are happening with respiration and digestion and urination. All that is going to be processed from your autonomic nervous system. Uh, so this is the visceral sensory. That's the information coming from the autonomic nervous system. Any response like controlling peristalsis, controlling the contraction of the digestive tract to mix food and to digest it and to move it all along, is processed here in the visceral motor segment of the gray matter. And then all muscle movement is controlled here. And once the processing takes place, for a muscle reflex, for instance, that information is going to be sent out to the ventral root and out to the muscles for contraction. Here's a actual microscope view. Just be familiar with all of this various structures you should know about the spinal cord. So the gray matter of the spinal cord surrounds a canal, and it's surrounded by a thick layer of white matter. So what's happening here, back to here, is that information comes in, is processed by the gray matter. A lot of actions are automatic, like the autonomic nervous system. Other reflexes happen. So all the processes that occur in this gray matter, there's communication with the white matter, so that information can be carried in an ascending track up to the brain, and information can go a descending track and carry that information uh, out to the periphery or to the outside to uh, coordinate and to stimulate whatever's needing, speaking, uh, moving, all the activities that we do. Some activities are going to be controlled without any thought. Uh, Sometimes when we want to control a muscle, we're going to have to send information down to a descending track to uh, cause the muscles to contract based upon signals developed in the gray matter of the spinal cord. Okay, let's stop there.